So what we're looking at is mostly just reviewing. Because of the fact of having things like videos cut off and no one informed me, hey, this isn't working right. Like, I have my iPad with me. I had the recording. I probably could have just re-uploaded it for you. Sometimes, you know, issues happen, but as much as we try to check, like, if it looked fine to me, I figured out everything worked, and unless someone says something, it's hard for me to help you guys out. So what we're looking at right here is actually already in, I think, the video that probably cut off.
Yeah.
Okay. So we're going to go through this a little bit, talk about things quite a bit, and also in the next one we'll review lesson 2. So this is reviewing lesson 1, then we'll kind of review lesson 2, and then we'll take a sneak peek maybe at lesson 3, but we'll actually go over lesson 3 tomorrow. Okay, and I will adjust plans accordingly. So what is a conjecture? What can you tell me what a conjecture is?
You like a pattern?
I just realized something.
You gonna wipe that dust down?
Yeah, it's fine. We'll do the best. If you want, I'll give you the paper towel right after this, and you can wipe the bottom of your phone if you want. I'd rather have everyone be safe.
Isn't a
You wanna wipe that?
conjecture like the next?
So a conjecture, what was that, Bella? Ella?
Okay.
Sorry, last class, literally I had Bella that sits right here.
Yeah.
And I just had the class teach me, you know, in review for the test for tomorrow.
Mm.
And like about every 2 seconds, Bella's like, so that's why that popped out.
We should do that.
Was it like a pattern, basically?
Okay, so we're looking for a pattern. So do you find the pattern before the answer? Or do you find the answer before the pattern?
You found the pattern first.
Am I doing the wrong, if I do it the other way, am I doing the wrong thing?
Well,
No.
no, because the pattern is the answer.
The answer is 36 because 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and 6 times 6 is 36.
So perhaps you do it wrong if you find the answer before the pattern.
Yeah, because you have to find the pattern first to know how to get the answer.
Right. You could just guess, oh, I'm gonna say it's 34. Well, that can't be correct. You know what I mean? Like, you need to find the pattern first.
Sort of.
Yeah. Can't y'all just do what 16? 16 plus what equals 25? Okay.
But
then
it's
No,
4
because
times-
1 plus.
16,
You're
17, 18,
right.
19, 20, 21, 22, 23, 25. That's not.
Okay, he's actually not wrong.
What did
And
you say?
you guys aren't wrong either.
You can just 16 plus what equals 25.
Well-
But the thing is, so he says, hey, to go from here to here, I know I have to increase by 9. But what does that mean for the others?
They would also.
Do I increase by 9?
No.
No.
What does this increase by?
Well, it's not increasing, isn't it?
Just hold.
Mm-hmm.
7. 5. 3.
So the next one would be 11.
There still is a pattern.
Adding 2 every time.
Yeah. Add 2 more than what I added previously. 3, 5, 7, 9. Could I still come up with the same answer? Yes.
Yeah.
My brain did exactly what yours did.
Yeah.
But I had at least one person in the other class that went and told me this first. I'm like, you're not wrong. That's completely right to look at it that way too. To make a conjecture doesn't always mean that you're going to take the exact same path. You're not always going to see the exact same pattern. Because our brains will process things a little bit differently. Do I need to be able to come to the correct answer? Yes, but there can be more than one way. So don't be afraid of that. All you need to do is back your conjecture by what you're seeing and have everything work out.
Mm-hmm.
Now, to me, it's a lot easier to see the perfect squares. You know, 1 times 1, 2 times 2. You know, this is the exact same thing. 1 times 1 2 times 2, 3 times 3. You know, those are all that. Or I could say 1 squared, 2 squared, 3 squared. It's all going to get us to the right answer, but in slightly different ways. And so the conjecture would be that, you know, I have a series of squares, perfect squares, and so the next one in the pattern is 6 squared. Or I could say it's always going to be that position times itself. Or I add 2 to the previous number, and I add 2 more to what I've added to the previous number. Those are both reasonable conjectures. Okay, how about this one? Make a conjecture about this sequence.
You add 1 over 1. You add 1 every single time. Cause
It would be B. No, it wouldn't. I was wrong.
no,
Don't
it would
listen
be D.
D.
Well, what's the conjecture?
Well, the
You add
conjecture.
1.
Well,
You
yeah.
add 1? What do you mean?
Well, you
Okay.
Add 1 over
Right,
1 to
right,
each
yeah.
fraction.
Okay. Cause
Girl.
I'm trying to explain what it is. I'm not even trying to be extra. Cause 1, you add like plus 1, and it doesn't matter that it's just like a single because 1 equals 1 over 1. So
Okay.
that's what it is.
Ah, so she's like 2/3 plus 1 is like 1 over 1. So she's just literally saying that's going to be 3 and that's going to be 4.
Yeah, that's what I was gonna.
I
I
see.
I would sort of agree with that, but it bothers me a little bit because I know that I can't take 2/3 and add 1 over 1 and have it equal. This does not equal 3/4. It does for the pattern, but it's not truly like adding 1.
Yeah,
You
it
have to.
bothers me too. Like, I
Okay,
looked at
D,
it.
I'm just trying to.
No, but the thing
No,
is, you
there's
saw the
nothing
right
wrong
pattern.
with it, Kawan. Like, yeah, that
You
is.
saw, you saw like the right pattern, but as far as exactly how that gets explained,
Like,
this
I
is a
just-
little fishy there. It's a lot easier for me to go, oh, well, I add 1 to here, and I add 1 to here, and I get 3 and 4, 4 and 5, 5 and 6.
Like, I looked at it and I saw the denominator becomes the numerator.
Uh-huh,
And
now
then
that's the other thing that people
The
see.
next number in the sequence becomes the new denominator. Like,
Okay, so here's what she's seeing.
yeah.
Yeah.
Is, oh, the denominator becomes the numerator, and then I add.
Mhm.
Denominator to numerator, add.
That's a lot of work to just say 1 plus 1. I mean, 2
Yeah.
plus 1.
And both of them are conjectures that work.
But it's like I looked at it and that's what I saw. Like, I
Okay.
didn't see the add 1.
But either which way, we should end up with
Right, 7 over
7
And I
x.
have a question.
Uh-huh.
If you were like to say, make a conjecture about this and explain your reasoning, would you take the reasoning that I gave?
I would.
Okay.
Okay? How about this one? We have to determine if the conjecture is true or false. We are given that we have a triangle.
It's true.
It's equilateral.
It's, well, we don't know if it is or not. We know that A and B and C all are angles of 60. If those angles are 60 each, is ABC, the conjecture is that it's an equilateral triangle. What does equilateral mean?
All
All
the
the
sides
sides are equal.
yeah.
Equal sides. Will all the sides be equal? They have to be for those angles to be the same. If any of the angles were a different number, you would have to have, if any of them had a different number, you're gonna have a different length of side. It's the only way that it can work.
I overthink this right here. Because I was like, oh, 60 times 3 is 180 and triangle is supposed to be like 180 degrees something.
Yeah.
I don't know what I was thinking, but like I just thought I overthink it and all you have to say is yes. I was doing too much basically because I was just like doing all this math.
Yeah, it might be for that. Okay, how about this one? Given angle 1 and 2 are supplementary. What does supplementary mean?
90 degrees.
Nope.
No, 180.
Supplementary, they have to add up to 180 degrees. What is the one that's 90?
Complementary.
Complementary. So these two add up to 180. So the conjecture that they gave was that these two angles are congruent. What does congruent mean?
Equal to.
Equal to what? Equal to 180?
They're
Equal
like,
to each other, the same.
like the same size.
So they're going to be the same size, the same measure. They're equal to one another. Do we know that those two are equal from the given? Why not?
Because they didn't give us like a number.
We don't have numbers. Is it possible that it could be 90 and 90?
Possible.
It's possible. Could it be 1 and 179?
Yes.
Yes.
Could it be 10 and 170?
Yeah.
Oh, sorry, yeah, 10 and 170. Here they give an example of 70 and 110. They're adding up to 180. It's not necessarily congruent because there's a whole lot of other choices that can
So
add up to
I
that
have a-
180.
Sorry, I have a question. So I remember on the homework we did the thing with tables,
Mhm.
and we made the
That'll be coming up, the truth tables.
yeah, and we made what it could be like
Uh-huh.
each option like okay. So is that kind of what this is like? It could be, but because there's a chance that it's false like overrides it and it's false.
Completely, 100% correct.
That's
Okay,
what I
we
did.
haven't gotten to truth tables on this quite yet, but it is in that same direction where if in order for these conjectures to be true, they have to be true in all cases, not just one. Okay, this is the and situation. But that was a good link. Okay? This one sometimes can be hard to see too. Here we know that we have a triangle. We have an R, an S, and a T. We know that two sides are congruent. The conjecture is that RS is congruent to ST. And it's saying that this side and this side are congruent. Do we know for certain?
No.
We don't know. We don't know the measure of any of these sides. We just know that two sides are congruent. Which two? Lack of info. It could be that RS is actually congruent to TR, or that ST is congruent to TR. This is like those truth tables that we saw in lesson 2, which comes, after this. That there are many, like there was at least 2 instances where this could be false, and only 1 instance where this could be true. So the conjecture doesn't work. Okay? Find the next one in this sequence. What comes next? What's the first thing you notice when you look at that pattern?
It's like a positive, negative.
Yeah, that's the first thing I noticed too. It's flipping signs. Positive, negative, positive, negative, positive, negative. So the next one I expect it to be
Positive.
positive. So that already rules out those. And then the next one should be,
Another
Negative.
negative.
huh. So even just by looking at that, I'm already thinking it's that.
Yeah.
So the conjecture could be that it's constantly flipping signs. But is that enough information really to figure out what comes next?
Maybe it's like oh, never mind.
If there was another option, like another, like if they'll say on C it said 3, -4, but that would still be a positive and negative, so you need to know what's the pattern to know which numbers fit.
Yeah. So how do I get from here to here?
Times negative.
Or
So you say, take this and
Divided by
multiply
negative 3. So
Yeah, actually, I would agree. So either I'd have to multiply by negative 3 on this, or take this and divide by negative 3. And I need to divide by negative 3 in order to get the positive. And then this one here. And then divide by the negative 3 again,
you get negative.
and I get negative 1.
So the conjecture is divide negative 3.
Yeah. Literally, I take each term and divide by negative 3. So in some cases, it's easier to work out the answer than the conjecture, and some where you have to do the conjecture to find the answer. Is that making sense? Now here's where we really start to lose people, right? Let's start looking at this next one, because then it gets really wordy. And people start kind of glazing over. We have these different statements. We have P, Q, and R. And not all of the statements are covered every time. Okay? Questions can involve any combination of whatever statements they make. And here they get with P and R. P and R. Now you can also see that, you saw it in your textbook. This here is P and. It's including. Okay? This here is or. It's kind of dividing it. It's like one or the other. Okay? But here we have P and R. What is a compound statement? What's a compound statement?
like it has 2 answers.
No.
It would be like when you combine the two with and or.
Yeah, it's just where we combine the parts. Okay, we combine 2 parts, and it's either going to be combined using the and or combined using the or. Okay? It really only has one answer, but it does have the 2 parts. Okay? What parts are we concerned about here? P
And R.
and R. So we don't have to worry about Q at all right now. Okay? Don't even, not even on the radar. So P says 12 plus negative 4 equals 8. Okay? So that automatically gets rid of these 2 because these have not equal to 8. This symbol means not equal. Okay? And we can have the opposite of things. We'll see that in some of the later examples. So we know it's not B and we know it's not D. And R. A triangle has 4 sides. Okay, both of these, the triangle has 4 sides. This is true, this is false. Well, how do we know which one is the correct choice? Is P plus negative 4 equal to 8? That's true. A triangle has 4 sides.
Nope.
So if I combine those 2, is that compound statement true or false?
False.
Why?
Because of the word and, it's including, and if at
Because
least
of
one-
and I have something that's false, it makes the entire thing false.
Mhm.
Are we losing anyone? Maybe to sleep? Stand up if you need to, okay? There's no one behind you. So we have false, because even though the first part of the statement is true, having that second part false makes the entire thing false. What happens if I put or? What if it was P or R?
Then the answer would be A,
Then the answer would be true. Why?
because or is saying if at least one is true, then the whole thing is true, because you said or.
Yeah.
And
So
is
what-
including both.
So, and I need both to be true, or all I need is one to be true. What happens if they're both false?
Then it's just false.
Then it's just false. Okay. Here's Q or R. Once again, we need to come up with a compound statement. Now, does it matter if I write the compound statement or if I start looking at whether things are true or false first?
No, you would wanna write it down first.
I think it's a matter of personal preference.
Mhm.
You know, you could do it either way. You don't have to stick to one method or another, other than I would suggest that whatever you're comfortable with, stick with it. But just because whether you start with, you know, this side or that side doesn't make a difference here. Okay? So which do you want to do? Do you want to write the compound statement first? Let's take a vote. Who wants to write the compound statement first?
I mean, I usually do.
So 3, and then how many people would rather start looking at whether these are true or false?
I do all of it. Like,
Oh yeah, we're gonna have to do the both, but which one do we wanna do first?
oh, right, if it's true or false.
You would rather do true or false first?
Well, how
Yeah.
are you gonna write a compound statement without knowing if it's true or false?
Yeah, you,
Ah, okay.
I mean, you could, you just wouldn't.
Well, the thing is, the compound statement is gonna be the same no matter what,
Yeah,
right?
yeah.
So, it doesn't matter which way we do it, other than we need to pick the way. So, was there a clear majority as to whether we're doing the statement or the true or false first?
The true or false,
True or
I think
false.
the one.
Okay, let's do the true or false. Q, a right angle measures 90 degrees.
that's true.
R, a triangle has 4 sides.
False.
Okay. And we dealt with or. All we need is 1.
So the answer's gonna be true.
So the answer already is true. Now we can do the compound. A right angle measures 90 degrees, or a triangle has 4 sides. Right angle measures 90 degrees, or a triangle does not have 4 sides.
So it'd be A.
So what happens if I did it the other way around? You know, where I just try to figure out, instead of this true false first, I go, okay, right angle measures 90 degrees, or a triangle has 4 sides. That's possible. Nope. Nope. Could be that. And then I went, okay, well that's true, that's false. We have an or,
Either way.
Either which way, you get to the same end. So, you know, don't be hung up with exactly which way you do it, but make sure that you cover both parts. That we have the compound statement and that we see, is that going to be overall true or false based upon our and or our or. Now here's where they start to get a little tricky. What does this mean?
Opposite, like not.
Not, it's the opposite. I want to find a way to negate that statement. Okay? So not P means I have to take this and show the opposite. Not equal to.
So could you eliminate A?
That automatically eliminates A. Not P is 12 plus -4 is not equal to 8. Or R. R is a triangle has 4 sides.
They're both false statements.
So right now this is false. This is false.
So everything's false.
Everything's false.
So
And then C's incorrect because you didn't negate R, you negated P.
I would agree. We have not equal to 8, but we didn't add in the does not, it has.
So it's
Okay? So we have to learn those little symbols. We have to know what this means in front of a letter. We have to know what this means. We have to know what this means. They're strange, but it's their symbology, their shorthand to make this go faster. Okay? How about this one? What's a truth value? When asked for what a truth value is, what does that mean?
I just know it means like this compound sentence stuff. Like, oh,
What are the possible answers for a truth value?
Oh, they're not very true.
Not
sorry,
necessarily,
it's also
no.
asking you like which is true. Like, I don't even know how to explain it.
It's actually quite simple. Truth value, there's only two choices.
True or false?
True or false. There's no maybe. Either the entire thing is true or the entire thing is false. There's nothing in between. Based upon whatever else happens to be in that statement and how they set it up. So here, Q and not R. Where do you want to begin? Carson, where do I begin?
Repeat what you said again.
Where do I begin? Do you want to start with the compound statement, or do you want to start looking at the truth of Q and not R?
Q and not R.
Okay. So we don't need this one. Doesn't deal with P at all. How about Q? Is that true?
yes. Sorry.
A right angle measures 90 degrees.
Yes.
Alright? Not
R is not
R.
true.
So a triangle
Triangle don't have four.
does not have 4 sides. A triangle does not have 4 sides. True or false?
Untrue.
Okay? So right now, Q and not R is already looking to be true. So we can probably get rid of these guys, right? Now I need to
Is
do
it
what?
B?
Well, what's the compound statement here, Joseph?
True. A right angle measures 90 degrees and the triangle does not have 4 sides.
Okay, right angle measures 90 degrees and a triangle does not have 4 sides. Because we negated that second one, the R, with not R. We doing okay on that?
Mm-hmm.
Why
I
is
think-
it simpler than all the like distance and stuff like that?
I don't know. Some people would probably argue this is harder in some ways, just because it's the logic.
See, I love logic, so this is really good for me.
She's in her happy place.
Mm-hmm.
Okay. How about this one? Where would you begin, Kwan?
Put a spot there. I tried like true or false.
Okay.
And so
So what do we have? We have to find
not P and not Q.
not P, not Q.
But
So how do I make this
no,
not?
I put the not next to the R, not the Q.
No, you're right. Thanks for catching that. So how do I make P not?
Well, first of all, you get rid of A and C because there is like a cross and equal. Right? I'm sorry. I'm kind of just
Well, you're right, except for the fact that I probably would have made the change up here, just to keep track of it for me. Granted, I know it's not necessarily the same way on paper or computer, but I completely agree. She says, hey, you can already get rid of A and C because that doesn't have that symbol. You know, she skipped that step and just went straight to, hey, A and C don't fit. How about Q? A right angle does not measure 90 degrees.
Well,
Before people complain.
So-
Okay.
both of those say it doesn't.
Okay.
Wait,
That's. But what's the difference?
What is
One's
true?
one is false. So
So let's look at 12 plus -4 does not equal 8.
Is it true or false?
that's true. That's false.
False. A right angle does not measure.
Sorry, it's not. It's day.
There's more than one way to get to these answers. But there is only one right answer. Okay? This one takes a little bit of thinking, but it's based upon all the stuff that we've talked about so far. Consider two statements A and B. So we know how we have statement A, and we have a statement B. And we know that this one is true, and this one, no information. We're given that statement A is true. Do we know anything about statement B?
No.
It exists.
It could be A.
It could be not. It could be D, cause not B, right?
But we don't know what B is.
Or
So where are we going to guarantee that we're right?
A. Because you know A is true.
We know A is true. So not A is never going to be true.
We don't know about B.
But we don't know anything about B.
let's say R,
B
B.
could be true, could be not true, we don't know. To guarantee that we're right,
It has to be A or B.
it has to be A or B.
Cause it's like.
This one maybe, this one maybe, this one definitely not. But we already know that A is true, and all we need with an or is one part to be true. Okay? Does it make so much more sense when you talk through it rather than just staring at it yourself? Did you guys actually talk doing any of your work while I was gone? Or just stared at the screen a whole lot? And it doesn't help when things cut out. Sorry about that. Okay.
Is your favorite color neon green?
It's green, not necessarily neon green. Why?
Ooh, that's
Cause
my
I was
favorite
just
color.
looking at all your stuff.
I just like green.
It was on the slide that we
Yeah,
did.
green. Like not all greens, but most greens.
Okay, so do you like the green that the Open SM2 is in?
Sure.
Or the one that you wrote your name on?
Do you like your eyebrows?
They need to get done.
Okay. So, believe it or not, you know, previously you looked at using the logic, you looked at some Venn diagrams. What was a Venn diagram? I should have had that mask for today. I don't have that mask. I have a Venn diagram mask. If not now, then.
Where's the middle?
That's
That's horrible.
I don't
Okay.
get it.
like when, but when.
Well, let's do a little review on these truth values too, before we go further. So, truth tables are where we looked at things like P, Q, and we said, okay, well, P and Q. If P is true and Q is true, we know the overall thing is going to be
True.
True. Okay. How about if P is true, but Q isn't?
The whole thing's false because there's an and.
Both need to be true because the and. One of them isn't, so it ends up being false. How about if this is false and this is true?
It's still false.
Still false. How about false and false?
It's false.
So with an and, both sides need to be true. We agree?
Agreed.
Okay. How about if I have P, Q, and this is P or Q. If this is true, true, the whole thing is
True.
how about true, false? True. True. Huh. How about false, true?
False.
True.
Oh, there's only one
True.
has to be true.
Only one of them. As long as one of them is, it ends up being true.
That's false.
And this is false. But in this case, when we have an or, we have much more possibilities of being true. And then it doesn't help when they add in, oh, well, not P. And then they say, and Q, or R. And you're like,
I've never seen that one.
No, there was one. 20. 25 is like P, Q, not P, and then not P and
and it seems
Yeah.
crazy, and you're like, oh, this is beyond my thinking. No, it's perfectly okay. You just have to be slow and methodical about not P. Okay, what does that mean? Okay. Then combining the two, and both of them have to be true. And then, or, we have to look at the truth value of this compared to the truth value of this, and only one of these needs to be true. It's not hard, it's tedious. It takes time. Just like before where I said, don't be afraid to take up half a page. Don't be afraid to write things out. Keep track of it. And we do better when we write it out rather than just try to keep it all in our brains. Like, I'm a very visual person. I do have a brain but it gets distracted very easily. How many of us have that ADHD sort of mentality of, oh, wait.
You always need to do something.
No, it's just a matter of I do better if I write it out.
Oh.
And this way, if I get distracted by something, I can go back to, oh, that's what I was doing. If you try to keep it all in your head, because some people are like, oh, I don't want to put marks on the paper. I don't want to take up room. I don't want to be messy. It's easier to keep track of things if you're being messy on the paper like this than trying to just keep a track of all of it right here. Because chances are you lose something up there. Okay? So here's where we go next. And this is what we're going to be looking at tomorrow. But I really felt it was useful to kind of review this today just to make sure that people caught some of those details. Okay? Where have you seen if-then statements before?
Science.
Science? Well, where in science do we use if-then?
Hypothesis.
Hypothesis. What if I told you that this in math is the hypothesis, and then this one is a conclusion? It's similar language, but it's not quite the same. Your if-then statement is a hypothesis and a conclusion that are combined as a compound statement. Okay? If this, then this is the case. Okay? And then we also have these new big words. You're like, some of those we might have seen before. Some of them are like, yeah, we're a little unsure where we're going with that. Okay, so we're going to be looking at that a little bit more. How are we doing on time? And now we have about the same 5 minutes, but I think that's what we're going to end for today. Unfortunately, the review took up a little bit more than I would have liked.